Good evening, dear students. You all know, due to yesterday's sudden suspension and today's bandh, we could not take the last two classes in which I plan to complete the first half portion of the third unit. Therefore, I'm planning to explain briefly the topics presented in the first half portion of the third unit through these videos. If you listen to these videos, I hope it will be helpful for you to understand the topics which I already have given to you through my notes. So, in the first half portion of this unit, we will discuss about the introduction to quantum computing, linear algebra for quantum computation, Dirac-Brand Kate notation and their properties, Hilbert space, block sphere, concept of quantum computer, classical bits and qubits. We will discuss up to that. So, from this, let me tell you first, from this portion, the broad question we can expect in exam or you can expect in exam, maybe they may include the differences between classical and quantum computation. Then you may study the importance of studying linear algebra in quantum computation. Then we should learn about the properties of Dirac-Brand Kate notations, and we will discuss about Hilbert space and block sphere also. So, the first topic that comes here in case of quantum computing, we should know what is quantum computing. So, you all know that computation, it is related somewhat with calculation. Now, quantum computing is a computation method which uses the properties of quantum mechanics, and especially we will discuss about the phenomena like superposition and entanglement, which are used to process information and perform calculation in quantum computers. And why should we study quantum computing? What is the advantage of quantum computers? The main thing, the first of all, the main difference between classical computers and quantum computers is that the quantum computers acts very faster than the classical computers. Its speed is very high. And so let's learn about the differences between them point wise. So I have presented the differences, I have listed out some differences in this table. So as I said, the first point is, in case of classical computing, it is obvious we use multipurpose computers which follows the laws of classical physics. Whereas in case of quantum computing, some high speed computers are used which follows the rules of quantum mechanics, which are governed by the laws of quantum mechanics. Especially in this case, we should discuss about superposition principle and entanglement. But before that, let us understand the basic logic unit which we use in case of classical computation and quantum computation. So, in case of classical computation, informations are stored in classical bits. So, how the classical bits are presented are understood by classical computers. So, it uses basically different values of voltage. Suppose some voltage level above than 5 voltage will be represented by the bit 1. You all know about binary bit system, I guess. 0 and 1, 2 bits are there. So, the bit 1 is represented by a voltage, suppose a voltage above than 5 volt, and bit 0 will be represented by the voltage values, all the voltage values which lies below 5 volt. Similarly, suppose existence of charge somewhere in our circuit represents bit 1, then absence of charge will represent bit 0. Now, in case of quantum computers, instead of these classical bits, we use a new type of bit system. They are called qubits. So these qubits, you may think these qubits are actually related with electron spin states and polarization states. Now classical bits can take either value 0 or 1 at any instance, whereas these qubits can have any value of 0, 1, or we may consider sometimes a linear combination of both the states. So this thing is new in case of quantum computer. In classical computer we can have only two values for the bits, either 0 or 1. But in case of qubits it can take the value 0, it can take the value 1, or it can take a linear combination of both 0 and 1. So a qubit, a quantum classical bit, you may think like tossing a coin. While we toss a coin, we get either head or tail. We can never get a combination of both the situations. But in qubit, there will always be a possibility to obtain a situation in which we will get a superposition of both the states. So these qubits are represented by various spin states of electron. Electron can have up spin or down spin. Now you know that in quantum mechanics everything is related with probability. So suppose we are making measurement on the spin state of electron. Now from quantum mechanics we will the answer will be something like, in certain state we will get the answer like there will be 60% probability of getting up spin and 60% probability of getting down spin, 40% probability of getting down spin. So that means the answer we are obtaining in case of quantum mechanics involve both the spin states. It is involving a linear combination of both these. So there lies the difference between quantum computer and classical computers. Classical bits can take only two values, either 0 or 1, whereas qubits can take infinite values. It can be 0, it can be 1, or it can be any linear combination or maybe some complex combination of both the states. Now so we can say the output in case of classical computer, it is deterministic. We can get certain answers for certain problems. So if we get a particular input to a classical computer, say 2 plus 2, it will always give the answer 4. Now that type of problem is not done in case of quantum computer. So some quantum computers are always involved with some kind of probabilistic answers. So if we repeat the same procedure again and again in quantum computer, we may get answers with different probability. So it will always give us some probabilistic answer. The output will always be probabilistic, not deterministic like classical computer. Now in case of classical computers, we use logic gates. You know about AND or NOT gates, I guess. So these are few logic gates. AND gates represents multiplication operation, some operation like multiplication. If both the inputs are in 0 state, then the output will be 0. If one of the input is 0 and the other is 1, so 0 into 1 is 0, you know. So the output will also be in 0 state. And NOT gate represent if input is 0, output will be in 1 state. So these are simple logic gates which are used in case of classical computer. Whereas quantum computer use some quantum gates that we will discuss later. So the name of some quantum gates are X, Y, Z, then H represents Hadamard gate, and there are CNOT gates. So the operations, logic gates follow the laws of Boolean algebra. So the operations of classical computer also follows Boolean algebra, whereas quantum computers follow the laws of linear algebra that we will discuss next. And classical computers deals with macroscopic technology. Here circuit is implemented in macroscopic technologies, whereas in quantum computers circuits are implemented in microscopic technologies. And in case of classical computer, data are processed by in sequential order. The answer we will get bit by bit. Any answer will be carried out bit by bit. So we will obtain answer in sequential order. Whereas in case of quantum computer, a lot of operations can be done simultaneously. So data processing can be carried out at parallel instances. So these are few differences that you should remember. So these differences between classical and quantum computing, very important for your exam also. Please prepare them properly.